So I was looking for torso models, right? Like my friend here. I think I'm going to use this one. So I thought today, because we've been doing quite a lot of back anatomy, haven't we, which is a lot of detail and a bit too much, I thought I'd go back to something that's really relevant, really useful and reasonably straightforward, and we'd look at the arterial supply, so the arteries of the upper limb, alright? And I thought, well, if we're going to look at the arteries of the upper limb, we want to start from the great vessels, right? We want to look at the arch of the aorta and the branches that come off it. And looking at my big expensive models in the lab, like this this gender indeterminate model here, they're a little bit variable, aren't they? From the arch of the aorta, we're supposed to have three major arteries popping off from it. To the left, we have the left subclavian artery goes to the left upper limb. We have the left common carotid artery going up to the head and neck. And on the right side, we have the brachiocephalic trunk, as we like to call it these days. Used to be called the innominate artery, if you come across that. Diving off to the right, because of course the arch of the aorta goes left, so we need the brachiocephalic trunk to get us over to the right, which then splits into the right common carotid artery and the right subclavian artery, which goes off down here. But looking at the torso models, and yeah, I knew this was here, two of our torso models have got those three branches from the aortic arch, but that one model has got two brachiocephalic trunks, left and right. So we've got two brachiocephalic veins, that's normal, coming from either side. We'll talk about those another day. But two brachiocephalic trunks. What that does is that highlights how you should not trust what I say, you should not trust what the textbooks say, you should not trust what you read on the internet, you should not trust what your lecturers say, and you should not trust what these beautiful, incredibly detailed, very expensive, absolutely excellent anatomical models tell you. Because sometimes we make mistakes, sometimes we're not entirely correct. That may well be an anatomical variant. If it is, it's a fairly rare one. Embryologically, it's entirely possible. Why do you think they keep producing new editions of textbooks, huh? Is it because the textbooks are struggling to keep up with the rate of new anatomical knowledge discovered every year? No. The reason they keep putting out new textbooks is maybe they found a nicer way of writing something, maybe they've drawn some new nice pictures. It's a good way of selling new textbooks, but also they fix the errors that are in the textbooks. But of course, by fixing one group of errors, they often introduce another group of errors. I know, I write textbooks. So sometimes, textbooks are not infallible. I know I'm not infallible. I'll say stupid things every now and then. At least when I'm recording videos and editing, hopefully I'll notice. But I haven't. There have been some errors in my videos. Have you noticed them? If not. Anyway, it's an important thing about learning. It's an important thing about information and knowledge, right? Use multiple sources. Don't assume that some seemingly credible source is absolutely correct and infallible, because that's not true. Something else I do in my videos is I tend to simplify, right? And sometimes, simplify is maybe the wrong word. But no, I try to simplify because I'm trying to help you learn the important things that you want to learn. And sometimes by simplifying, I have to take out some detail, but I also have to fake some things, right? Not that I'm telling you things that are wrong intentionally, it's just that sometimes not all the detail is in what I'm showing you, and there are exceptions to what I'm saying. Anyway, right, today's topic. The arterial supply to the upper limb, which I'm sure you already know a little bit about. Okay. Okay, so take you apart again. We should find the aorta coming out of the heart, so that's coming out of the left ventricle, goes up and curves around, so it's curling towards the left side and it's curling posteriorly to get to the posterior thorax where it's going to run down. And so that's the arch of the aorta. And we see these three branches here. the brachiocephalic trunk, the common carotid artery on the left, and the subclavian artery on the left, right? The common carotid arteries go up the neck, go up to the head and do all that fun stuff. And then we see that on the right we have the brachiocephalic trunk goes off to the right and divides, and look, there's the right subclavian artery arching out here and the left subclavian artery arching around there. So this muscle here, this is the anterior scalene muscle, right, going down towards the rib from the neck. So it's running in this gap here. Now the subclavian artery does a bunch of interesting things. I think one of its most interesting things, and we can talk about this another day as well, is that it sends off the vertebral artery. All right? So this is cool, isn't it? So there's the brachiocephalic trunk there. There's the common carotid artery on the right. And look, here's the subclavian artery, and we see a bunch of branches, and that's the right vertebral artery. And can you see how it's going up through those foramina in the transverse processes of the vertebrae, and going up and going through the foramen magnum to get into the skull and supply blood to the brain. Oh look, see, can't get away from vertebrae. I've managed to sneak them in again after the last couple of weeks. So that I like. I like how the vertebral artery is a branch of the subclavian artery. So that happens on both sides and goes back. But then, and this is where this model becomes completely useless, is the subclavian artery disappears off into the upper limb. Now can you see, here's the first rib here, right? And this artery changes its name as it progresses out into the upper limb. And we see this in the lower limb as well. The femoral artery changes its name as it passes down the lower limb. So the subclavian artery here is the subclavian artery where we can see it, but as it passes the first rib, we're going to change its name. It's moving into the axilla, right? The armpit is the axilla, so it's going to become the axillary artery once it passes the first rib. And we can see a bunch of branches here, but can you see how the axillary artery is going to run through the axilla and out into the upper limb? I'll tell you, if you were a stealth assassin, right, and you wanted to cause major damage to somebody, if you stuck a knife in the axilla up here, there are an awful lot of important structures, like this massive blood vessel, which when you're like that, they're not protected. They are protected like this. Just saying. So if you see somebody with an injury to their axilla, rare as it might be because the axilla is usually reasonably well protected, you should worry, you should help that person. And we'll talk about how to stem bleeding as well as we work our way through the arterial supply to the upper limb. Anyway, stealth ninja assassins aside, you can also see how, look, the brachial plexus is tightly wound around the axillary artery, and in fact the parts of the brachial plexus are named relative to their position around the axillary artery. I need a pectoralis minor muscle, and I haven't got one on here. I don't think I've got a model that shows pectoralis minor and the arteries, so we'll just have to pretend, all right? But the axillary, the pectoralis major muscle, we've talked about. Pectoralis minor muscle, we might have mentioned when we were talking about the movements of the shoulder, but it's a smaller muscle that goes from the ribs up to this coracoid process of the scapula up here, right? Now, do you see how pectoralis minor then covers over part of the axillary artery? And by doing that, we break the axillary artery into three segments: the first part, second part, and third part. And the second part is behind pectoralis minor. So the first part then runs from the first rib to the border of pectoralis minor. Second part is deep to pectoralis minor, and the third part continues on a little way. Then we change its name again. The reason I mention this is because the axillary artery has a number of branches, and we say that the axillary artery has one branch in its first part, 2 branches in its second part, and 3 branches in its third part. So if you absolutely have to remember the branches of the axillary artery, that's a starting point. This is very boring, but the branch from the first part of the axillary artery is the superior thoracic artery, which kind of supplies blood to the superior thoracic region. And then the 2 branches from the second part are the lateral thoracic artery and the thoracoacromial artery. So that suggests the lateral thoracic artery is going to the lateral part of the thorax. The thoracoacromial artery, well, thorax and acromion. Where's the acromion? That's the acromion up here. So we're going up and around the scapula and giving off a whole bunch of other branches. The acromion is the bit you can feel, right? That's your superior bony point there, part of the scapula. And then the 3 branches of the third part of the axillary artery are the subscapular artery. Guess where that's going? To the subscapular region around here. And then you've got a couple of circumflex humeral arteries. So circumflex going around. So we have the anterior and posterior circumflex humeral arteries. So those 3 make up the 3 branches of the third part of the axillary artery. God, that's incredibly dull. But the anatomy is interesting and important, because why, whenever we see a joint like the shoulder or the elbow, do we see so many arterial branches and so many anastomoses? Do you know what anastomosis is? Do you know what I mean by anastomosis? So an interconnection between arteries, or an interconnection between veins, but in this case I'm talking about arteries. So we see a whole bunch of arteries disappearing off around the scapula and going up, and obviously we're supplying the muscles of the shoulder and all the other structures around here, but they anastomose with blood vessels on the other side of the joint, coming from the humerus, that are going back up, like these collateral, like these circumflex humeral arteries and that sort of thing. Why do we have so many anastomoses and so many collateral arteries at every joint in the limbs? Well, the reason is because if we have just one artery supplying all the blood to a limb, if that artery gets occluded or severed, then there is no blood going to that limb. Our limbs are incredibly important to us. And particularly to survival when we, some time ago when we were evolving very slowly. And I say we, I mean our predecessors, right? So we have this collateral circulation around the shoulder. So if a blood vessel gets occluded, or blood is impeded from passing through that major artery somehow, then it's possible for a collateral circulation to cross through those other arteries around the shoulder. So whereas blood was flowing in this direction up from the humerus in here, and blood was flowing in this direction around the scapula, the flow of blood, if it can't go through the axillary artery, instead we might see more blood going through the collateral circulation around the shoulder and then into the upper limb. So some of the flow of blood would be reversed, but we would maintain a blood flow to the upper limb. And we can demonstrate this and we can see this when we have bleeding, because we find it can be difficult to stop the bleeding. And I'll talk about that when we get all the way down to the hand. All right? Okay, so axillary artery passing through the axilla. We're steaming along now. We're getting into the upper limb. We're getting into the brachium. Right? We've gone through the shoulder. The deltoid muscle's falling off. So here's the axillary artery surrounded by the brachial plexus. And there's another muscle, which also isn't on here. Oh yeah, it is. Don't know if that's very helpful. But do you remember teres major and teres minor, right? Passing, again, go and look at the shoulder video, but where we have teres minor and teres major passing from the scapula to the humerus, where the axillary artery passes teres major, we change its name again and we start calling it the brachial artery, and it's in the brachium. And that's what we see here, the brachial artery. and it's running with some branches of the brachial plexus. So this is going to be the ulnar nerve running around here, because it's going to run around the funny bone, right? This is going to be the median nerve that comes through here. So the brachial artery, here's the biceps, here's triceps. Look, we've got this lovely groove here. So essentially, this is all very superficial. It's protected because it's in here, right? You know, it's in there. So it's not, you know, it's close to our body, so it's fairly safe. But you can, right, in here, if you go fiddling around, you can feel your triceps, you can feel your biceps, and in this groove in here, you will find your brachial artery. You should find the pulse of the brachial artery. There's mine. And if we had some ultrasound, we'd be able to see the median nerve and the ulnar nerve, and we'd see those guys split as they get to the elbow, right? So again, this is a site where the brachial artery is fairly exposed along with those big nerves. I did have a friend, actually, I think he crashed his mountain bike once and impaled himself here and speared his artery. Lots of blood everywhere. We'll come back to the brachial artery. Okay, so brachial artery, and then we're pretty golden until we come, so here's the cubital fossa here. So as we get into the elbow, it's still the brachial artery, and look, it's just going deep to these muscles, and then you can see how the brachial artery divides into the radial artery. I know it's radial because look, there's the thumb, and you know your radial pulse is here on this side. So there's the radial artery, and here then is the ulnar artery. And the ulnar artery, look, that's disappeared, that's gone really deep. Can we even find it if we take this off? Oh, we can. We can see there's the ulnar artery there. Oop. And it's running with the ulnar nerve. You can see the median nerve there as well. So the ulnar artery is pretty deep within the forearm. And we can see it's sending off some other branches. So in the forearm, we've got the ulnar and the radius, right? There's my thumbs, this is the radial side. Between the bones is the interosseous, osseous, bone, between. So between the ulnar and the radius is an interosseous membrane, right? So as the ulnar artery gives off some interosseous branches which go nice and deep, and means that they send blood to the posterior compartment, your extensors, right? And the deep anterior compartment. So basically, the ulnar artery gives off some interosseous arteries to supply blood to the extensor compartment and deep muscles of the forearm and forearm muscles over this side, that sort of thing, right? Lots of lovely branches. The radial artery is fairly straightforward in that it just swoops around down towards the base of the thumb. Now the other thing that happens is that from these arteries we see recurrent and interosseous branches, and you see this, I don't know, can you see this here? You can see this is the superior ulnar collateral artery. A lot of detail you probably don't need to know, but my point is again that so the recurrent arteries are going back up. That's why they're called recurrent. But there are arteries going back up to the elbow and arteries going around the elbow. So if this brachial artery becomes occluded, then blood can flow around the collateral circulation to continue into the forearm, right? Collateral circulation again. That's the point I'm making. Focus on the radial artery and the ulnar. Now the ulnar artery, that is. If I put this back on then, I just want to visually remind you that the ulnar artery is pretty deep. It appears again down here, down towards the wrist, and the radial artery is similar, although it's in a bit of a gap, but it's a little bit more superficial here. So these arteries are superficial and at risk at the wrist. But can you see, like, here's the flexor retinaculum. Can you see how the ulnar artery goes over the flexor retinaculum with the ulnar nerve? So it's not going to be caught out in a confined space like the median nerve does, which we can see popping out here. Right, now the radial nerve, this actually goes around posteriorly. Alright, so here's the radial artery here, and it comes around the thumb, and that's it there. So this is the anatomical snuff box, right? You've got your two tendons there. So the radial artery goes through the anatomical snuff box, goes around the thumb, and then it goes through this space between the thumb and the first finger to get into the hand. And when it gets into the hand, can you see that arcade there? So you see this arcadey loop? So the radial artery and the ulnar artery meet and they form these arcades, right? So we have these superficial palmar arches, or we have a superficial palmar arch and a deep palmar arch, both formed from the radial artery and the ulnar artery meeting in the hand. Of course, these things are, oh God, these things are pretty well protected in the hand. You've got some really nice, you've got your palmar aponeurosis, you've got layers of all sorts in there, so they're quite well protected in there. And the same thing goes for a wrist. Once you get into the hand, you can see there are lots of little branches, digital branches, all sorts of branches disappearing off to supply lots of blood to the hand. There's lots of little muscles in there. We do have a really good blood supply to the upper limb and to the hand. You can see posteriorly there are lots of branches as well, right? What this means is that if we do have a deep cut within the hand, how do you stop blood flowing? I mean, if you have a very deep laceration here, you can put pressure on it. If you're lucky, that'll stop the bleeding. But if it doesn't stop the bleeding, it's difficult to just compress the radial or the ulnar arteries, or to apply enough compression around here, which is very bony, to stop the blood getting to the hand and stop the bleeding. What might actually be easier for you to do is to find the brachial artery here. And remember, this is the single site at which blood flows from here to here. And it's often a lot easier to stop arterial flow through the brachial artery and then limit the arterial pressure at the hand and help to stop bleeding in that way. Or maybe you'll put a tourniquet up here. Maybe up here that might work, but it might be easier up here to stop blood flow to the distal arm. Just an idea, you know, if you're in a mess, don't forget, if you are using a tourniquet, you have to release it regularly. If you want to know about tourniquets, you should read much more about that and don't just take my advice. I'm just saying, if you think anatomically, you can use your anatomical knowledge to help you if you're struggling to stop the bleeding of a major artery in the upper limb. All right, okay, there we go. The arterial supply to the upper limb from the aorta through, on the right side, the brachiocephalic trunk, the subclavian artery, which becomes the axillary artery, the brachial artery, which then divides into ulnar and radial arteries, and the ulnar and radial arteries pass to the wrist. The radial artery passes posteriorly around the thumb to get into the hand, and both the radial and ulnar arteries meet to form arches within the palm, so superficial and deep palmar arches, which then give off lots of arteries to the other bits of the digits and so on. And at the elbow and at the shoulder, we see lots of collateral branches coming from those arteries, which might allow a collateral circulation if needed. Cool. It's a pretty tidy piece of anatomy, isn't it? Okay. Right, see you next time. I hope that was helpful.